June 15, 1944. Kyushu, Japan. The dawn air is still, cold, and empty. Inside a concrete bunker near Moji Bay, radar operators hunch over green screens glowing in the dark. The line sweeps. Silence. No blips. No movement. Outside, the air smells of salt and static. A lieutenant yawns, confident that any American aircraft would take hours to reach the mainland. The nearest Allied base is thousands of kilometers away. The radar scope stays clean. Then, a distant hum, a vibration so faint it might be wind. The officer steps outside, squinting at the horizon. Nothing. He turns back toward the bunker and freezes. Above the rising sun, glinting at impossible altitude, dozens of silver shapes drift through the clouds. The first bombs fall before the alarm sounds. The ground shakes. The radar screens remain blank. Japan's defense network, built on watchfulness and warning, had gone blind. Because somewhere, far beyond the curve of the Earth, a new kind of machine had taken flight. One that could strike from beyond radar range. And with that, the Pacific War entered an age no one on the ground could yet understand. In 1942, Japan stood at the height of its imperial reach. From Burma to the Aleutians, its flag flew over half the Pacific. The Imperial Japanese Army Air Force and Navy Air Service had conquered by speed, precision, and confidence. The art of striking first and overwhelming the enemy before he could react. But by 1944, that confidence had turned brittle. The war's balance had shifted. The U.S. Navy dominated the sea. The American industrial engine, relentless, faceless, mechanical, was now producing planes faster than Japan could fuel them. And while Tokyo's engineers still trusted in courage and eyesight, their enemies were learning to see with radio waves. Japan's radar network, once considered state-of-the-art in Asia, had fallen dangerously behind. In 1941, Japanese scientists had begun developing primitive air warning systems based on British and German designs. They built the Type A radar for coastal detection and the more advanced Tachi 6 for early warning. Yet progress was slow. Their oscillators were weak, their vacuum tubes unreliable, and the entire system depended on imported German components that never arrived after the U-boat blockade tightened. What radar Japan possessed worked only at short range, ideal for spotting low-flying bombers approaching at 10,000 feet, not giants cruising above the clouds at $30,000. Instead, Japan relied on eyes. Observation towers lined the coast, manned by volunteers with binoculars and field phones. Reports were relayed to Central Command via voice lines, slow, human, and fragile. The system had served well when raids came from nearby carriers or the China coast. But when the war stretched beyond geography, when machines could cross oceans, it was doomed. By contrast, the United States was building something unimaginable, a bomber that could reach Japan without ever being seen. This concept had been born in 1939, long before Pearl Harbor, inside the quiet offices of Boeing in Seattle. The Army Air Corps had demanded a weapon of reach, an aircraft that could fly 3,000 miles, carry 20,000 pounds of bombs, and operate at 30,000 feet, beyond enemy interception. Boeing's answer would become the B-29 Superfortress, the most expensive and complex weapon of World War II, costing more than the Manhattan Project to develop. While Japanese scientists were still calibrating their shortwave receivers, American engineers were inventing a new sky. The B-29's pressurized cabin allowed crews to breathe where the air was too thin for propellers to bite. Its four Wright R-3350 engines, each nearly 2,200 horsepower, could push the aircraft through the jet streams that crippled smaller planes. Its central fire control system, guided by analog computers and remote turrets, meant gunners could aim and fire without ever seeing the enemy. And its most devastating advantage, its range, allowed it to strike Japan from bases far beyond Japanese radar coverage. By 1944, this technological divide had become an abyss. The Japanese early warning grid stretched only 400 kilometers offshore. Beyond that, the Pacific was a blind horizon. Radar technicians at Ominato and Kisarazu could detect American B-24s from the Aleutians or short-range raids from China, but not the superfortresses flying from the Mariana Islands, nearly 2,500 kilometers away. To the Japanese, those islands seemed too distant for any bomber to reach, until the Americans built runways that turned geography itself into a weapon. The U.S. capture of Saipan, Tinian and Guam in mid-1944 was the turning point. Within weeks, engineers laid down 10,000-foot runways carved from coral, capable of launching fleets of B-29s. The skies over Japan would never again be empty. And yet, Japan's high command did not believe it possible. Their intelligence officers assumed that at such range, American planes could not carry heavy bomb loads, that the attacks would be token raids, symbolic gestures. They were wrong. The B-29's long wings, sleek fuselage, and high-altitude operation made it almost invisible to both radar and interceptor. When the first formations appeared over Yawata and Nagoya, radar stations failed to detect them until bombs were already falling. Operators stared at blank screens as their cities burned, unable to explain what their machines could not see. The war had entered a dimension Japan's instruments could not measure. A war fought not by proximity, but by reach. By late 1944, the Pacific had become an ocean of silence for Japan's radar network. The Imperial Navy's once formidable perimeter, from the Philippines to the Kuriles, had been shattered. Islands that once acted as sentinels were now graveyards. When the Americans seized Saipan, Tinian, and Guam, they didn't just capture land. They captured distance. From these runways, newly constructed by U.S. Seabees, the B-29 Superfortress could launch directly at the heart of Japan and return without refueling. It was the first time in history that a bomber could fly intercontinental missions, 3,200 miles round trip, while carrying a heavier bomb load than any plane before it. Japan's radar horizon was built for a 500-mile war. The B-29 operated in one spanning continents. The Americans hadn't simply built a large airplane, they had engineered absence, the ability to strike without detection. The B-29's smooth aluminum skin was polished to reflect less radar energy, though no one yet used the word stealth. At altitudes above 30,000 feet, Japanese radar signals, already weak, dispersed through temperature layers before ever reaching their targets. When the pings returned, they were swallowed by atmospheric clutter. Japanese operators at Kushiro and Fukuoka often mistook B-29 formations for high-altitude weather fronts. Their radar, the type B-29, could barely detect a large aircraft beyond 150 miles. And even then, the altitude estimates were wildly off. The result was chaos. When interceptors scrambled, they climbed too low, too late, and too slow. The B-29s flew serenely above, untouchable and unseen. Meanwhile, the Americans were flying with their own radar. Each B-29 carried the AN/APQ-13 navigation and bombing radar, capable of mapping coastlines and cities through cloud and darkness. In an irony of war, the bombers could see Japan better than Japan could see them. Even when storms covered Kyushu or Honshu, the B-29s found their targets with mathematical precision. The Japanese command, bewildered by the accuracy of raids arriving from invisible directions, concluded that the Americans had deployed phantom aircraft from submarines or secret islands. No one could accept that technology, not sorcery, was guiding the strikes. When the first major raid hit Yawata in August 1944, it carried more symbolism than destruction. Yawata was the steel city of Japan, home to the Imperial Iron and Steel Works, the industrial heart of the empire. 47 B-29s flew from China under Operation Matterhorn, dropping bombs from a height no Japanese gun could reach. Most missed the target, but the psychological impact was enormous. The Japanese Army Air Defense Command realized for the first time that the home islands were no longer isolated fortresses. 2 months later, the raids from the Marianas began. Now the formations numbered in the hundreds. The ex-Yeoman's Bomber Command, under General Curtis LeMay, turned the Pacific into an aerial highway. Each sortie took 15 hours, 3,000 kilometers of open ocean. Every mile of that journey was invisible to Japanese radar. The first blips appeared over land, seconds before the bombs. The word used in Japanese command diaries was chilling. Mushin. Appearing from nothing. The Imperial Japanese military had always fused warfare with philosophy. They trusted in the spirit, seishin, over the machine. Radar was tolerated but never revered. Many senior officers considered it coward's technology, preferring visual combat and interception. This culture of intuition became lethal when faced with American empiricism. The U.S. didn't guess. It calculated. When radar stations began reporting phantom contacts, Tokyo headquarters accused operators of panic or incompetence. One radar officer, Lieutenant Tanaka of the Ominato base, was reassigned after filing repeated reports of undetectable raids. His final note in the logbook read simply, "They come from where we cannot look." By December 1944, Japan's radar grid was in disarray. Many stations had been destroyed by carrier strikes. Others lacked spare parts. Power shortages forced operators to shut down at night, precisely when B-29s preferred to arrive. The Empire's eyes had gone dark just as the enemy's vision reached perfection. From this moment, warfare ceased to be symmetrical. Japan's world still operated on human scale. Pilots, lookouts, telescopes. America's war had become industrial, algorithmic, invisible. The Pacific, once a natural defense, had turned into a highway of sound and mathematics. And as Japan's cities began to vanish under the falling fire of unseen bombers, one question echoed through every command bunker. How do you fight an enemy you cannot find? In the control rooms and radar bunkers of Japan's home islands, war had become an exercise in disbelief. Radar operators, most barely trained beyond theory, sat in silence as explosions bloomed beyond their comprehension. They were not cowards. They were witnesses to the collapse of an entire worldview. The Japanese military had built its doctrine on sight. The pilot's eyes, the lookout's vision, the commander's intuition. War was supposed to be something a man saw. Yet the B-29s existed beyond that sensory universe. Crews on the ground stared into empty skies, hearing the faint thunder of engines that should not have been there. The air raid sirens came late, sometimes after the bombs. Many believed it was supernatural. Some called it ghost air, Yurai Kuko, the air of spirits. Others whispered that American planes had found a way to become invisible. For the first time in Japanese history, the soldier's courage meant nothing. Valor could not stop what could not be seen. Before 1944, Japanese air defense followed a predictable pattern. Early warning radar detected an enemy formation. Ground controllers vectored interceptors to climb and attack before bombers reached their targets. It worked against low or medium altitude raids. Against B-24s or carrier planes, the system was sufficient. But the B-29 broke every rule. It flew at 30,000 feet, faster and higher than any Japanese fighter could reliably reach. The Ki-44 Tojo and Ki-84 Frank, Japan's best interceptors, struggled at those altitudes. Engines lost power. Oxygen systems froze. Pilots blacked out. Worse, by the time radar even registered a faint trace of the incoming formation, the bombers were already overhead. The Japanese tried every possible countermeasure. Spotter balloons were raised above cities. Anti-aircraft guns were recalibrated for higher ceilings. Fighters were scrambled on pattern patrols, circling blindly in hopes of intercepting unseen intruders. Yet each adjustment only revealed the futility. Without radar warning, interception became guessing. And guessing cost fuel, aircraft, and men. The United States exploited this weakness ruthlessly. Flying from the Marianas, B-29 squadrons varied their approach altitudes and routes. Some flew in from the north over Hokkaido, others from the south past Iwo Jima. Japan's fragmented radar network could not unify the picture. By the time headquarters received the scattered reports, the data was hours old. The bombers were already gone, replaced by smoke. Every failed interception eroded more than strategy. It eroded faith. In Tokyo's war rooms, generals began speaking of mujo, impermanence. For the first time, the empire felt smaller than the sky. To understand why Japan failed to see the B-29s, one must understand radar's nature. Early radar systems relied on short-wavelength radio pulses that scattered easily in turbulent air. Japan's islands, surrounded by mountains and humidity, made radar operation unstable even in clear weather. The Allies, meanwhile, had moved to microwave radar, using magnetron generators that produced far more precise, long-range signals. Japan never developed a comparable magnetron. They were fighting with the radio equivalent of candles against searchlights. Moreover, Japanese radar doctrine was static, literally. Most sets were fixed installations, bolted to concrete emplacements. The Americans, however, had learned mobility. Destroyers, submarines, and even aircraft carried radar. The B-29's own systems, the AN/APQ-13 and later the AN/APQ-7 Eagle, allowed bombers to navigate and target cities through darkness or cloud. In effect, America's planes carried Japan's missing eyes. Japanese scientists understood the gap but could not close it. In 1944, laboratories at the University of Tokyo and the Navy Technical Research Institute begged for copper, vacuum tubes, and precision instruments. None came. The blockade and bombing campaigns had starved industry. In a bitter irony, the very bombers Japan could not detect were destroying the factories that might have built the technology to stop them. By the end of the year, desperation turned to invention. Engineers attempted acoustic radars, giant trumpet-like devices meant to hear aircraft engines at long distance. They built hundreds, dotting the hills around Tokyo and Osaka. They looked impressive, monstrous even, but they were useless. At high altitude, the thin air carried sound too slowly. The B-29s were invisible, and now they were silent. What Japan faced in 1944 was not simply a superior enemy. It was the arrival of modern war, a battle where the human eye no longer mattered. And as the B-29s returned night after night, burning Japan's cities one by one, the men in the radar bunkers began to ask a question their training could not answer. If we cannot see the enemy, do we still control our own sky? The B-29 was more than an aircraft. It was a system. Every flight represented the merging of physics, logistics, and intelligence into a single instrument of precision. From its conception, it was designed not to fight for air superiority, but to exist above it. American engineers approached the war as a problem of reach and data. Each radar wave, each wind current, each temperature gradient was charted, calculated, and fed into mission planning. The bomber's course from the Marianas to Tokyo was a 3,000-kilometer algorithm. The Japanese saw instinct as a weapon. The Americans saw information as victory. Every B-29 carried an integrated suite of radar and navigational systems that transformed the chaos of the Pacific into a grid of certainty. The AN/APQ-13 radar guided them to the coastlines. The Norden bomb sight, coupled with gyro stabilization, let them drop with meter-level precision from 6 miles up. And the CFC fire control system turned each turret into a miniature computer. Even without visual contact, the bomber group functioned as a synchronized machine. men acting as neurons in a vast mechanical brain. At night, the glow of the radar scopes inside the pressurized cabins cast the crew in pale green light, soldiers illuminated not by fire, but by mathematics. They did not see Japan, they measured it. For the Japanese command, this new warfare created an existential terror. The enemy was not merely unseen, he was unreachable. In the early months of the raids, officers at the Air Defense Command in Tokyo refused to believe that planes could fly so far undetected. Reports of beyond-radar attacks were dismissed as errors or sabotage. The concept violated everything their doctrines had taught. That defense began with warning. That war was a matter of honor between visible foes. But as city after city burned, denial gave way to despair. Psychologists later studying captured Japanese documents described a phenomenon of technological shock, the paralysis of command when the enemy operates beyond known limits. Radar officers, once proud of their skill, were reduced to passive witnesses. Pilots, ordered to scramble into the night, flew without direction, guided by nothing but instinct. Many never found the bombers. Others froze to death at 30,000 feet trying. To the civilians, the B-29s became myth. Newspapers called them Shinryaku no Kaze, the wind of invasion. Rumors spread that the bombers carried invisible shielding, that they could vanish into the stars. For a society steeped in the spiritual symbolism of the divine wind, kamikaze, this new wind was not divine, but mechanical. The empire had entered the age of the machine, and it could not follow. As the bombing campaign intensified, a new moral dimension emerged, one that haunted both sides. To the Americans, the B-29 represented the ultimate efficiency of industrial war. Each sortie was a triumph of planning, a proof that science could deliver victory with fewer human risks. Yet even among the crews, there was unease. They watched fire consume cities they could barely see, and knew that behind every glowing patch on their radar screen were thousands of lives. Some pilots later wrote of a strange detachment, a feeling that the war had become abstract. They weren't fighting men, they were erasing coordinates. One B-29 navigator described it as the loneliness of seeing death as data. To the Japanese defenders, the moral wound cut differently. Their belief in the virtue of sacrifice, in fighting face-to-face, was shattered. The enemy no longer offered the chance of combat, only annihilation from the stratosphere. The samurai spirit, long glorified as the heart of national honor, was useless against geometry and altitude. A pilot who survived the night raids over Osaka later said, "We were brave men fighting ghosts." The shock extended beyond the military into Japan's cultural identity. The empire had defined itself through harmony with nature, through the wind, the mountain, the sea. Yet, here was an enemy who had turned nature itself, the sky, into an instrument of destruction. American scientists had harnessed air currents, jet streams, and temperature layers to their advantage. What Japan revered, America measured. This clash of worldview, faith versus formula, became one of the war's most profound divides. The B-29 symbolized modernity itself, rational, detached, efficient. Japan's officers faced a revelation far greater than defeat. The realization that courage without comprehension is blindness. By late 1944, the cultural tension reached its breaking point. Commanders ordered radar operators to continue tracking even after raids passed, as if faith alone could restore sight. Pilots trained in swordsmanship were now told to read magnetic bearings. The old world was dying, and the new one spoke in frequencies. The night of August 20th, 1944, began like any other on the Japanese home islands, still, humid, deceptively peaceful. At the Yawata Steel Works on Kyushu, workers moved through the endless rhythm of war production. The blast furnaces glowed, the sparks flew, and the hum of machinery echoed across the valley. To them, the war still felt distant. American bombers, if they came at all, struck the coasts or southern islands. The radar posts at Ominato and Moji Bay reported nothing. The sky was clear. The Empire's heart was safe. Then came the low, steady hum. At first, it was mistaken for thunder. Then, faintly, the tremor of engines, deep, layered, growing. The radar screens remained blank. The operators checked their dials, tapped the consoles. No readings, no blips. The system was functioning, but the air was empty. A few minutes later, Yawata vanished in light. 47 B-29 Superfortresses, flying from bases in Chengdu, China, crossed the East China Sea under the name Operation Matterhorn. They flew higher than any Japanese aircraft could reach, from a direction no radar could sense. At 31,000 feet, they dropped their bombs on Yawata, Japan's primary steel-producing center, the industrial core that fed its tanks, ships, and weapons. The material damage was limited. Only a few direct hits struck the furnaces, but the psychological devastation was immense. It was the first time in the entire war that Japan's home islands had been attacked by heavy bombers. Commanders in Tokyo were incredulous. No interceptors had been launched. No early warning reports had arrived. When military attachés questioned radar operators, the replies were stunned and simple. There was nothing on the screen. Some suspected malfunction. Others accused technicians of negligence. But when identical failures repeated weeks later over Nagasaki, Omura, and later Nagoya, the truth became undeniable. The enemy was striking from beyond radar range. The Japanese Air Defense Command scrambled to understand how. Calculations showed that the bombers had approached from over 1,500 miles away, farther than any known aircraft could fly. Engineers rechecked signal strengths, recalibrated antenna arrays, and increased transmission power. Nothing worked. At high altitude, the American bombers were ghosts, gliding in from the edge of physics itself. From the American perspective, it was a triumph of engineering and endurance. The B-29 crews in China had faced logistical nightmares, fuel shortages, treacherous Himalayan routes, and unpredictable weather. But their confidence was unshakable. To them, the mission was proof that the war could now leap over geography. They were not raiders. They were heralds of a new age of reach. As the raids increased in frequency, Japanese commanders realized they were no longer fighting a local war. The home front was now a battlefield, and the radar network, their first line of defense, was collapsing under its own limitations. Even when operators detected vague echoes, the readings were inconsistent. Signals arrived too late, distorted by temperature inversions and mountain interference. Interceptors scrambled blind into the sky, chasing nothing. In October 1944, during a raid over Nagoya, radar posts detected a formation of unidentified objects that vanished mid-scan. Investigators concluded it was atmospheric distortion, but hours later, the city burned. The operators had seen the B-29s, but only after the bombs were already on their way down. The Japanese High Command began issuing directives filled with contradictions. One order demanded radar stations report all anomalies. Another insisted they ignore false returns. Confidence in technology turned into chaos in a war that had once prided itself on spiritual clarity, where every soldier was trained to die with honor. The idea of an invisible, unreachable enemy broke something fundamental. For the first time, Japan's officers felt helpless before science. It was not fear of the bomb or the plane itself. It was fear of not knowing. The enemy was not simply stronger. He was smarter, colder, beyond emotion. He did not rely on intuition, nor courage, nor prayer. He relied on mathematics, and mathematics never tired. Radar operators began reporting phantom echoes, perhaps out of guilt, perhaps out of desperation. Tokyo's command logs filled with confusing reports. Some claimed hundreds of aircraft where there were none. Others reported clear skies in the middle of firestorms. The system had entered hysteria. In November 1944, the B-29 Bomber Command, newly based in the Marianas, began large-scale operations. From now on, every B-29 that crossed the Pacific did so unseen until it was already above its target. Kyushu, Nagoya, Kobe, and Osaka. All were struck before their alarms could sound. Cities burned in perfect sequence. The Japanese called it the invisible fire. The Americans called it precision. Each raid widened the rift between what Japan could imagine and what it could endure. The empire had spent decades teaching its people that victory was a matter of spirit. Now, they faced an enemy whose spirit was calculation itself. The sound of engines became the sound of inevitability, and as Japan's cities glowed beneath the clouds, the officers in Tokyo finally began to realize what was coming next. The day the invisible war would become total. It began at 1 a.m. Idrikan Sanantwandridrin, March 10, 1945. The sky over Tokyo was black, moonless, heavy with mist. The few remaining radar stations around the capital reported nothing unusual. A light drizzle fell on the sleeping city. Somewhere in the distance, a faint rumble could be heard, like thunder far out at sea. Then, without warning, the air raid sirens screamed. By the time the first operators saw movement on their screens, the attack had already begun. Over 330 B-29 Superfortresses, flying from Tinian and Saipan, descended to just 7,000 feet, far below their usual altitude, and unleashed 1,700 tons of incendiary bombs on the world's largest wooden city. The radar beams, calibrated for high-altitude detection, missed the low-flying bombers entirely. Tokyo's defenders were blind. Within minutes, the capital was transformed into a firestorm. The wind caught the flames, turning narrow alleys into tunnels of heat. The bombers' radar navigation systems, the AN/APQ-7 Eagle, guided them unerringly through smoke and cloud. Each crew saw the target not through their eyes, but through glowing radar screens. In the dark cabins, the pilots and bombardiers watched the shapes of entire districts flicker across phosphor displays, releasing their payloads with mechanical calm. Below, the city burned at over 1,800 degrees Celsius. Asphalt melted, rivers boiled. More than 100,000 people would die before sunrise. For Japan's high command, the Tokyo raid was not only a tragedy, it was an awakening. Until that night, they had believed the B-29s were precision weapons meant for industrial targets. But this was annihilation. Radar stations around the capital had failed to track the raid's approach, their signals overwhelmed by thermal interference and radio jamming. By the time interceptors were launched, they found only smoke and heat. The bombers were already gone, vanishing back into the mist. General Hideki Tojo's successors in the Defense Ministry demanded answers. The engineers at the Navy Technical Research Institute offered none. The American bombers had flown through the gaps in Japan's radar grid. Holes left by destroyed stations, power shortages, and outdated equipment. The enemy had not merely used science, he had exploited absence. For many officers, the sense of violation was personal. To be unable to see, to fight, to even locate the enemy, it stripped them of identity. The warriors of the air, once heirs to the samurai code, were now reduced to silence and confusion. Reports from the following weeks describe pilots circling aimlessly above the ruins, searching for bombers that had already crossed the Pacific horizon. The architect of this devastation was Major General Curtis LeMay, commander of the WWII Bomber Command. LeMay understood what Japan could not, that the war had become a contest of endurance, not honor. He ordered his crews to abandon the high-altitude precision raids that scattered bombs over small areas and instead strike low. Below radar, below defense, and below comprehension. The B-29s were stripped of guns to carry more incendiaries. Crews flew without formation lights, guided solely by radar beacons from Saipan. The sky became an equation. Every aircraft a moving coordinate in a system of total destruction. Japan's interceptors, still dependent on ground-based radar, never had a chance. When they scrambled, they found no targets on their scopes. The bombers' low approach blurred into ground clutter, and the defenders, flying blind, often collided or crashed before even reaching the enemy. For Japan, the illusion of defense finally disintegrated. After Tokyo came Nagoya, Osaka, Kobe, Yokohama. Cities erased one by one. Each time, the pattern was identical. Silence, then sudden fire. Radar readings delayed or corrupted. Reports inconsistent. Communications lines broken. The Japanese government began to censor its own military failures, insisting that enemy formations appear without pattern. But inside the command centers, the truth was whispered in grim certainty. The Americans could see everything. We could see nothing. By May 1945, the Imperial Air Defense Command's own reports conceded that enemy radar superiority exceeds all known estimates. In the same month, a new phrase appeared in their logs: beyond our vision. The nation that had once defined itself by clarity, the sharpness of the sword, the purity of discipline, was now lost in the fog of modernity. The final blow came not from bombs, but from realization. When radar technicians dismantled destroyed equipment in Tokyo after the raids, they found nothing wrong. No mechanical failure, no operator error. The systems had worked as designed, but the enemy had simply moved beyond their range of understanding. It was the end of Japan's technological faith. What had once been a proud belief in spirit and will was now replaced by fatalism. Officers no longer spoke of victory. They spoke of endurance, of delay, of dying with composure. In the weeks that followed, Japan began preparing for invasion. But in truth, the invasion had already come. Not from land or sea, but from altitude, from the invisible war that had already consumed their skies. And as the smoke from Tokyo's ruins drifted upward into the dawn, Japan's commanders finally faced the truth that radar could not show them. The future had arrived, and it had left them behind. By the summer of 1945, Japan's skies were no longer a battlefield. They were a corridor of inevitability. The B-29s came and went as they pleased, high above the shattered cities, each raid a metronome of destruction that the Empire could neither predict nor prevent. The war that had begun with surprise at Pearl Harbor now ended with surprise visited upon Japan itself, every night, from beyond the horizon of detection. The Imperial General Headquarters had become a place of disbelief. Radar reports were useless. Fighter units returned empty-handed, their fuel exhausted, their spirits broken. The Empire's great defensive ring, radar stations, spotters, listening posts, lay in ruins, bombed, starved of electricity, or abandoned. The officers who once plotted enemy movements now simply waited. In a Tokyo bunker beneath the Defense Ministry, a final assessment was compiled in June 1945. The report, written in precise technical language, contained a single line that captured the nation's collapse. Our early warning network is no longer capable of functioning as a system. It was not a loss of hardware. It was a loss of order. Japan's radar research teams, desperate to recover, began testing new prototypes, the Tachi-24 and Tachi-31 long-range sets. But production never passed a handful of units. Shortages of copper, vacuum tubes, and even basic electrical insulation crippled progress. By the time the first models were deployed near Tokyo Bay, the war was effectively over. They detected nothing before their stations were obliterated by the very bombers they were meant to find. In contrast, the American radar network stretched across the Pacific like an electronic empire. Every bomber group operated within a web of navigation aids, coded frequencies, and long-range communications. For every Japanese radar destroyed, 10 American transmitters filled the void. The sea, once Japan's shield, had become America's antenna. For those tasked with defending the homeland, the emotional toll was unbearable. Pilots who survived the night raids described the sensation of chasing ghosts, firing into darkness at enemies they could not see, then landing to find their bases gone. Many never returned to the air. Suicide missions, once symbols of honor, became acts of resignation. The Japanese Air Defense Command began receiving letters from radar operators and ground crews begging for reassignment to infantry duty. One wrote, "It is worse to hear nothing than to die." The silence of their screens became a form of punishment, a reminder that their country's pride had been built on illusion. Among civilians, panic mixed with resignation. Each air raid seemed to arrive from nowhere, each destruction unannounced. The population no longer trusted sirens or warnings. Entire neighborhoods slept in the open, believing that if the enemy was invisible, perhaps fate alone would decide survival. The Americans had achieved more than air superiority. They had achieved predictability. The B-29s flew with mathematical consistency, their routes calculated to exploit the gaps between Japan's shattered radar zones. From Saipan, Tinian, and Guam, missions launched with clockwork precision. In April 1945, B-29s struck Tokyo every 48 hours. Each time, Japanese defenses were caught unprepared. The Empire attempted one last innovation: the Fugo balloon bombs, meant to ride the jet stream to America. Ironically, the same atmospheric currents that shielded B-29s from detection were now used in a futile gesture of retaliation. Out of 9,000 balloons launched, fewer than 300 reached North America, causing minimal damage. It was a cruel symmetry. Japan's final weapon floated helplessly through the same winds that had carried its destruction. By June, the nation's leaders faced the unbearable truth. Their islands were defenseless. No radar, no interceptors, no factories to rebuild them. The only weapons left were belief and denial. Yet even those began to crumble as news of Okinawa's fall reached Tokyo. The Americans were not only above the clouds, they were now at the gates. The last surviving radar officer in Kyushu summed up the situation in his final report, written days before his station was abandoned. "We cannot see the enemy. We cannot hear him. We know only that he exists." That sentence marked the end of Japan's air defense and the beginning of surrender in spirit, long before it was formalized on paper. When Japan finally surrendered on August 15, 1945, its empire lay not only in ruins but in silence. The great cities were blackened shells. Their skies were empty. What had once been defended by radar arrays, searchlights, and squadrons of proud pilots now stood mute, staring upward at the same heavens that had betrayed them. After the surrender, Allied intelligence teams entered Japan with quiet curiosity. They came not as conquerors, but as investigators of a mystery. How could a nation that once led Asia in technology have fallen so utterly blind? The answer lay scattered across the islands, in laboratories, bunkers, and archives, preserved under layers of dust and disbelief. The U.S. Strategic Bombing Survey, USSBS, cataloged Japan's radar and electronic systems in exhaustive detail. Their conclusion was as blunt as it was tragic. Japan's early warning network had been courageously manned but scientifically obsolete. Investigators discovered dozens of half-finished radar prototypes in Tokyo University's basements. Elegant designs, crippled by poor materials and lack of standardization. One captured notebook contained a line that summed up the failure of an entire philosophy. We built eyes, but we never taught them how to see. The Americans were astonished by how much Japan had attempted with so little. The engineers had intelligence, ingenuity, and will, but not time. Wartime isolation had cut off the flow of crucial components: magnetrons, high-frequency valves, precision oscillators. Without these, Japan's radar sets were deaf beyond short range. While American scientists had entered the microwave era, Japan's remained trapped in the long-wave past. For Japanese officers and scientists, the shock was not simply defeat. It was revelation. They had faced a war no longer governed by valor or proximity. The empire that once prided itself on intuition had been undone by measurement. As one captured colonel told his American interrogators, "We were taught to trust spirit more than science, but spirit cannot detect a bomber." In post-war Japan, many of these scientists would go on to rebuild the nation's new identity, one founded not on faith, but on precision. The same radar engineers who failed to protect Tokyo would later design Japan's civil aviation systems, weather radar, and electronics industries. Their humiliation became the seed of transformation. For the United States, the radar war over Japan provided lessons that would shape the modern world. From the ashes of the Pacific, the Office of Naval Research and Air Technical Service Command began codifying radar doctrine, not as an auxiliary system, but as the core of modern warfare. The B-29's onboard radar became the ancestor of the navigation, surveillance, and targeting systems that would dominate the next century. The invisible war had proven something profound. Victory no longer depended on firepower alone, but on information. To control the electromagnetic spectrum was to control reality itself. It was this realization that birthed Project Cadillac, the first airborne early warning radar, and later, the Distant Early Warning Line (DEW) of the Cold War. Radar stations stretching across the Arctic, watching for Soviet bombers. The chain that began in the skies over Tokyo now circled the globe. For Japan, the end of war meant beginning anew under occupation. The few remaining radar stations were dismantled, their antennas rusting away along the coast. Yet amid the ruins, a quiet acknowledgement began to grow. That the B-29 had not merely destroyed Japan's war machine, it had dismantled an old idea of war itself. In diaries recovered after the war, one Japanese air officer wrote, "We lost the war not when our cities burned, but when the sky became invisible." Another added, "The enemy flew above our prayers." Their words revealed something beyond defeat, an awakening to the modern age. The empire of swords and courage had met the empire of science, and only one survived. In the years that followed, both nations turned their wartime lessons into the architecture of peace. The same radar principles that guided B-29s would guide civilian airliners. The navigation beams that led bombers through clouds would one day guide trans-Pacific flights. And in an irony history never forgets, the same Pacific winds that once carried firebombs would later carry radio signals, the invisible threads binding two former enemies in the shared silence of the air. When the last wrecked radar tower was torn down in 1947, a young Japanese engineer reportedly said, "We built towers to see war. Now we must build towers to see the weather." The war of invisibility had ended, but the age of electronic vision had just begun. When the fires faded and the sky fell silent, Japan awoke to a truth larger than defeat. The war had not been lost to armies or fleets, but to invisibility. The enemy that terrified its officers was not the B-29 itself, but the unseen power behind it. The power to know what others could not see. For centuries, the Japanese warrior had believed that battle was a test of the soul, a contest of will and endurance. But the 20th century had rewritten that code. The battlefield was no longer a field at all. It was a wavelength. Victory belonged to those who understood how to measure the invisible. In that sense, the B-29 raids were more than destruction. They were revelation. They marked the moment when warfare left the human eye behind. From that point onward, soldiers would fight not by sight or sound, but by signal. The radar beam, the radio pulse, the coded transmission, these became the new weapons of dominion. And yet, in that transformation, something profoundly human remained. Even as the machines grew smarter, it was still men who stared at the glowing screens, listening to the faint echoes in the dark, hoping to understand them. The war had not erased humanity. It had redefined its scale. Out of Japan's blindness came vision, not of conquest, but of comprehension. The same scientists who once strained to detect bombers through fog would go on to chart typhoons, to guide aircraft safely home, to map the very winds that had carried destruction. The fear that once came from not seeing would give birth to a generation devoted to seeing everything. The silence that followed the last raid was not merely the absence of war. It was the sound of a species realizing that the sky, once unknowable, could be understood. And in that quiet understanding, born from terror, humanity took its first step into the modern world, where victory would no longer belong to the strongest, but to those who could see beyond sight.